Okay, this is Loki. It's part of Ubiquity Robotics. This is the direct descendant of the ClubBot, in a way. So it's really Wayne's, mostly Wayne's handiwork. So basically what we have here is a full stack Ross Indigo robot that does everything any Ross robot can do. It's functionally equivalent. It has a navigation stack. It has a camera. So it has obstacle avoidance. It has odometry. It's running Ross Indigo. And basically what I'm going to demonstrate are just standard Ross nodes.
Yeah, I don't know. We had it for a second. It disappeared.
I thought I saw it up there. Now, where's this? All right, anyway, so one of the first things we can do is teleop. Okay, we don't have to show the screen.
Does the PC need to, do you need to toggle something on the PC to get it to come out?
Yeah, I've been toggling the screen.
There, now it's got a signal. It likes, seems to like that. Just here it does.
There we go. Yay!
There you go.
Yeah, and I see screens and you see nothing.
Yeah, I guess you may have to, if it's extended, you may have to drag it out over to this desktop.
Pay no attention to the man behind the curtain. Okay, I just wanted to show Ross nodes running, but you believe me, there are Ross nodes running.
Ross nodes running.
We can show this later. So I'm just doing keyboard teleop.
They're all Ross nodes running. Yeah, I saw some. I looked at the laptop computer.
So now I'm actually going to do some
No.
This is a Raspberry Pi with a camera?
This is a Raspberry Pi 2 working on a platform that is an Arduino Busino, which is an Arduino, but it has multiple UARTs. So the design of the robot is it's a Raspberry Pi, and it has a Raspberry Pi camera that's designed to look up, because our to do our slam, we plan to use fiducials mounted on the ceiling. We also have a bus that goes around for sonar sensors. So we can have, I forget how many, it's like 18 sonar sensors. I forget the exact number. 16, excuse me. And so we also have a node that does the obstacle avoidance based on the ping sensors, which are now around $1 a piece. So it's relatively inexpensive. We think this will sell when we're ready to sell it for around $200. And basically, it's the educational equivalent of a TurtleBot, but can run in a tabletop environment, and you can learn the full Ross stack by it. And it's sort of the going to be the low part of our bid for our bigger platform. And since we're writing the code to be pretty much compatible, you can develop your concept on the small platform, then move to the bigger platform. The bigger platform can move around 200 pounds. So the argument we're using is everyone has access to thousands or tens of thousands of cell phone apps. There would be 0 cell phone apps if you told every cell phone app developer, first you have to develop your cell phone. And that's where robotics are now. There are people who have wonderful ideas. I guess the big market is going to be elder care, right? Someone's going to have to change my diapers, and it ain't going to be my kid. So we're going to need some. Oh, well, yeah, except I don't think Pepper's big enough to lift me off the bed. But she might be embarrassed because I'm the head there. Anyway, okay, let me.
Yes. Yes.
So what I'm trying to do now is run RBX, Ross by example, to do the odometry, move 1 meter, turn, and come back.
Have confidence.
Pretty good. Now we'll try to do a 1/2 meter square. This one's a little dicier because this is just around the 1/2 meter.
It looks like close to a meter. You must trust your children.
What's that doing? What's that doing?
Your wire mixed up.
Let's try to do a 1/2 meter square. It's turning a little bit too far.
Is there a reason using black cardboard?
No.
The pen will make it wide enough, bigger than the tape.
Didn't quite.
So the blood won't show.
Pretty close.
Almost. It didn't go off the table. Pretty close. The thing is, it's pretty lightweight, and it's really hard to make a robot that small that's going to work on all surfaces. So some surface is based solely on odometry, and we have some slipping. However, once we get our full navigation stack in there, and we can triangulate on our fiducials, we'll have much greater accuracy. So we think our concept is viable. Thank you so much. And I'm not taking anything out of the box because we've got too much stuff already.
Thanks, Alan.
Oh, hey, Alan, how much for the magazines? I forgot how much those, you're going to sell those for.
Those are closely held.
Ah, great
Black
secret.
cardboard.
We're thinking around 1,000, but I can't. Don't hold me to that. Don't hold me to that. We have the costs very low, but that also is confidential.
Hi, my name is Mark Madonis. I work for Fetch Robotics, and so our major investor, SoftBank, also owns Aldebaran Robotics, and they make the Now and Pepper here. So when she wakes up, she's looking around to see if anything's like in her way, cords and so on. And she goes into artificial life mode. So hi. So she's looking around to see if there's anybody looking at her and so on. So she'll turn to look at you and pay attention. So you need to come this way. Come on. So Pepper is mainly sold in the Japanese market for now. If you're not familiar with Pepper, she is designed to be, it is designed to be an interactive robot. There is a tablet on the front here, as well as a computer in the head. There's cameras here and here, as well as a 3D camera in her eyes. There's touch sensors. It's very similar design to the Now in terms of sensor suite. There's touch sensors in the head, the hands, as well as in the base. There's infrared sensors scattered around the base, and there is capability for automatic charging with a charge dock. Let's see if I can get her to do one of. So the robot has this tablet on the front, which is its main interface. When you own a Pepper, you get access to the Aldebaran Robotics App Store, and you can download the different apps they have. Unfortunately, since this is for sale in the Japanese market, all of the apps for free download are in Japanese, which I don't speak, but let's see if we can come up with something fun. Let's see. So there's a number of different apps, which some are more interactive than others. So we'll have her sing about lunch. How about that? He's trying to look at me. Hi, yes. Hi. Hi. Hi.
やったー！当たったー！今のところ僕が提案して食べたくなった料理の回数はじゃーん26回中19回。
So anyway, so a lot of the apps are in the same sort of vein. There's a couple of games, a couple of apps to help you learn English, which I was surprisingly good at. There's several apps that the robot will take your picture.
What kind of drive system is that?
So in the base, what you can tell is when the robot is trying to keep me in focus. So in the base of the robot, it's a tripod base with 3 omnidirectional wheels. But they did not put a LiDAR in the base. They put some odd sort of line sensor infrared things down here at the very bottom. You can see the rig.
Is that a laser ranger or something?
Yeah. There is when you have a Pepper, they give you access to an SDK so you can write your own apps for the robot. Sort of, if you're familiar with ROS and RViz, there's a customized RViz. The robot does have Linux and ROS on board, and there's a very customized RViz that they have for the robot. So you get her to turn around here.
But this one doesn't have Watson. This one doesn't have Watson.
No.
Inside. Well, they've teamed up with IBM on that. Yeah.
So the robot, if you get anxious with a robot, you start kicking its base and manhandling it. It does sort of make a sad noise, like whoa. So anyway, so I'll stop that. So I'll end with one, do a dance. There's a theme song in here, which for some odd reason, when they do the theme song, it's done in a different singing voice than Pepper's normal speaking voice.
I'm not weird at all.
I don't know. It's Japanese. What can I tell you?
Sorry. お待たせしました。ペッパーのテーマソング。それでは僕のことが一発でわかる僕の主題歌をお聴きください。ミュージックスタート。
I apologize in advance. Good job, Pepper.
みんなよろしくね。
Yes, can I?
Okay, take the stage.
Question. Does it have a chatbot function?
No, well, I take it back. There's kind of a chat feature in the robot that's in Japanese. At least that's what I think it is. I can't really tell.
Okay.
No, actually, most of the apps are very much like this. They're very much just using the robot mostly as a puppet. And there's a very limited amount of interaction with the apps thus far. The robot's actually only been on the market for not even a full year yet. I think it was just last summer that it was released. So there is plans, as far as I know, of Aldebaran marketing this in other countries. Just Japan was the first biggest SoftBank, being that's their home territory.
And what's its purpose, as a companion, or?
As a companion, it's mainly targeted at doing interactive functions. It does have access to Wi-Fi. It does have speech synthesis, speech recognition. Of course, with all the cameras, it has face recognition. So in theory, you could make an app to do all kinds of cool interactive stuff, but that takes a little more development time. Apparently, those haven't quite made it onto the App Store. Yes, sorry. So they sell the robot sort of in a cell phone model. There's an initial purchase price of, I think, roughly $1,600. And then it's a monthly plan of $130 per month for 36 months. And when you have just like a cell phone, that means you get access to all the firmware updates, the App Store. All the apps are free on their App Store. Yeah.
It's still just like 4LG or something. I mean, it's just regular broadband, right?
So unlike a cell phone, though, its connection is through your Wi-Fi in your house. It doesn't have a cell phone
They don't even
connection.
give you broadband for that money?
Wow. So after you pay the price and you pay $130 a month and you do that for 6 months and you don't want it anymore, then
What do you call, man?
when you quit paying, what happens then?
You don't want to know what it does to you.
Yeah.
You make separate.
Pepper's cameras, I don't know. She just plays this theme song and she's 24/7.
Does it lose all functionality once you don't pay for it, like a cell phone would?
You'd lose access to the App Store, certainly.
Okay.
Yeah. But no, I don't think they come in repo or anything.
What's
Like the
coming
App
out of the
Store.
right eye? Why does the right eye look like it's got a...
Oh, so it's a structured light 3D camera? That's you're seeing the structured light infrared LEDs.
All right, typically we take a break right about now, but I want to see how many more robots there are.
Oh, hi everyone. I'm Lilia from Brew Robotics.
Yay!
Cam here asked me to do what I suspect he's been shamelessly doing for many years, namely to promote Nito as the best ever robot platform for both hobbyists and researchers. I'm going to be pretty brief. It's kind of getting late, but what I'm going to talk about is a poster that I presented recently at AAAI Symposium.
Oh, thanks.
Okay, so it's still a little not loud enough, huh? Okay. So at AAAI Symposium, there was a workshop where people were interested in a low-cost platform for human-robot interaction research. And I presented Nito as one of the possibilities for just a platform like that. So,
And I didn't even realize this till today.
that's right.
When was the presentation?
March.
Back in March. Back in
yeah.
March, right? Yeah.
Yeah.
Is that 2 weeks ago or something?
So what I looked at, I defined a number of features that people who, or researchers who work with robots to be used around people need to, for which robotic platforms that they use around people need to fulfill. So one of the things that when you work with people you might want is stable mobility. In particular, mobile robots allow a wider range of research topics, and wheel platforms in particular are stable and reliable. So Nito here has a differential drive with 2 wheels, spring suspension, has 2 caster wheels on the back. It can navigate over a variety of terrain. It is an indoor robot, and a lot of times for human-robot interaction research, people do it inside. But it can navigate over obstacles that are about 1.5 centimeters tall, crossover thresholds, without really any problems. The second feature is a robot platform should be used for any kind of, well, either hobby or research, especially with people, needs to have a nice sensor suite that would allow you to do robust navigation. Again, for a little platform like this, Nito has a pretty impressive sensor suite. The number one sensor that is the perfect sensor for doing any kind of mapping or navigation is a LiDAR. It's right here on top. It gives you a 360-degree view of the environment. We also have a 4-point bumper for any obstacles that are not detected by the LiDAR. We have 2 cliff sensors, so this robot will not fall over the stairs. We have a proximity sensor for wall detection or any other obstacle detection that can help you maintain the distance. And we have an accelerometer as well. So in combination, these sensors would allow you to do any kind of navigational task. Another thing that's important for human-robot interaction research, or if you are just working with robots on your own, is support for modularity. So as you can see here, Camp already gutted the robot, and instead of a dirt bin that normally would
That
collect
stuff could be in the
with
dirt bin.
vacuum, that stuff could be in dirt bin. So what you could do is place a platform on top of the robot. This dirt bin would go inside, and then you could put
There's a
certain
micro
kind
USB
of
jack inside there.
payload. You could say, put something else on top of it. You could put a Amiibo, you could put a robot head if you wanted to. You could put anything up to roughly 8 pounds, and the robot would still traverse the environment just fine. So, what I didn't mention yet is that you don't have to use whatever the robot code that's inside. All you have to do is connect to the robot via USB port, and you can get all of the sensor data from all of the sensors that are available on the robot, and you can send the motion commands to the robot. So you could, as Camp here has done, put, for example, a Raspberry Pi in it, connect it to your own ROS nodes, use ROS navigation stack, do SLAM, do mapping, do whatever you want. Of course, if you're interested in the mechanical engineering part of robotics, this is probably not quite the robot for you. But if you're more interested in the higher level autonomous navigation things and autonomous robotics in general, then this would let you get into robotics without having to know how the controllers work, how to put wheels together, how to do anything.
Lily, also the thing Steve was mentioning. Steve?
Yes?
And what's the name of the application?
Oh, Ansible?
Ansible? Yeah. Basically all the stuff that we've worked on to make that card, the Ubiquity group, and Ralph Knox BotVac node has been balled up into this Ansible, so it should make it easier to install and make the bootable card that goes in the Pi that talks to the BotVac. So
yes, easy peasy. You need to do nothing at all.
Max was talking about the documentation, so I've got a cheat sheet. I'm going to work up that documentation more and get it out on the mailing list. So folks that are interested in making Nito Pyroses, there should be a relatively easy path forward.
Well, the next point that if you work with robots and people together in the same place, what you might want to have is an static, non-threatening design, because you ideally wouldn't like people to get scared and run away from it, or think that this is a crazy robot. And, you know, dogs are okay with it, so probably should people. One of the most important things about having a robot like this as opposed to something that you might make yourself is that you have robust consumer-grade components. So you don't have really to worry about things falling apart on you. If you are extensively using it around people or something like that for, well, in this particular case it was research, then this will provide you with the stability that really none of the homemade robots at this point can. And if you wanted to do even less with robots per se and just wanted to see, okay, so if my robot is going to drive straight into somebody, what would that person do? Or if you wanted to see, well, hey, I want to approach a person and say hi on the robot, how would they react? Well, then you wouldn't even have to work with a Raspberry Pi or ROS nodes or anything like that, because this robot actually has Wi-Fi on it.
Actually,
and
that's not connected.
Well, that one's not, but they're connected, which is our most recent model. Has actually wireless and has an app, and with this app you can drive the robot around manually. So you could just pretend that the robot is going by itself when you're actually driving it around. So you could do all kinds of scaring people or doing pranks, putting pranks on them. So this is the app right there. And finally, what really cinches us is just how cheap this robot is. Its nearest competitor in terms of the platform would be Turtlebot. that if you're familiar with TurtleBot, you know that they run about a couple of $1,000s. And TurtleBot.
TurtleBot's $1,000.
$1,000 now. Okay, but $1,000. But they don't even have the sensors on board for that price. So with this, you're getting pretty good sensors already, and so 400 is the actual price. On sale, you could probably buy one of these even cheaper than that.
The TurtleBot makes clean floors.
That's wait for it. And when you're tired and done, you know it can clean your lab. So and
such a jerk.
And just to make sure, I'm not a marketing person at Nito promoting. I'm actually a robotics engineer, so I run these robots every day, so I can vouch that they're pretty neat.
Also, on eBay, you can get them for $200 or $300 functioning robots.
That's right. If they are used, but
even XV.
Out-of-pocket cost is really very low for all the cool stuff that you can do with this robot. Yes.
If I wanted to extend that and put effectors on it, like a grabber or something, do you have any sort of mechanical places to attach things?
Well, if you gutted it like this, right, and wouldn't be using it as a robot, you don't have a mechanical places to attach. You would have to superglue it or do something like that. But it will run with a payload of up to about 8 pounds.
On the shelf there.
The main thing is you have to put a platform that doesn't...
If you can put a shelf like that. So this one attaches to the dirt bin, but you could take this dirt bin out and you could just put something on top of this. Or you could skip the shelf and just put something on top of that. One of the problems with that, if you don't use the shelf, the advantage of using the shelf is that you would still get the LiDAR data. Otherwise, if you just put something in, you'll have a big blind spot. Right. More questions? All right. Thank you.
Thank you very much. I know a lot of us in the club use Nito
Big
robots.
fans.